All right, looks like we got a very good quorum here today. So let's talk about Metron and sort of the progress we made in the last few months, and we'll show you guys where we are, where we're going, and what you can expect from the project going forward. So, as you guys know, if you've played with Metron, we try to build it on all open source technology stacks. So the technologies that we use, the underlying enabling technologies for Metron are primarily either Apache licensed and Apache governed, or open source. So that's sort of our bias. The use cases for Metron are as follows. So our enabling use case is telemetry ingest and correlation, which is something we are currently working on. And that's sort of coupled against real-time search, which is enabled with Elasticsearch and Kibana. We also tie that into a cyber forensics use case. So we have a capability to capture network traffic and cross-correlate it with the telemetry from other sensors that we ingest into the system. And we provide a scalable solution for exploration of PCAP. We're expanding these use cases into additional things. So we're building an audit and compliance use case as an extension of some of the stuff we're doing, threat feed analytics, exploratory data analysis for the data captured in the data vault, building out a threat hunting platform on top of the Kibana interface, as well as building some features for Metron as a machine learning platform that we'll go over a little bit later on. So the target personas for Metron, if you guys have been following us, you sort of know the people towards whom we're targeting the system to. It's the SOC analyst, SOC investigator, and a security data scientist. Those are the primary personas. Secondary is the SOC manager, the forensic investigator, and also a security platform engineer who is responsible for setting up Metron, expansion of Metron, and then long-term platform maintenance. So let's talk about the use cases in more detail. So this is what currently exists for the telemetry ingest and correlation use case. At the very basic, what the platform does is it provides an extensible framework to hook up to sensors that are scattered throughout your domain. It gives you capability to ingest them into a data vault. Along the way, it gives you a stream processing pipeline. So it provides an extensible parsing solution for you to be able to ingest and onboard new sensors. So it provides the capability to do it in Java, do it with Grok, and a couple of things we have on our roadmap to extend it is the capability to process XML, and then also do custom scripting around parsing with JavaScript and other scripting languages, as well as to pipe JSON from other systems that can produce Metron compliant JSON. So that should be coming up shortly. In the last release, we introduced a DSL language called Stellar, which gives you a couple of capabilities scattered throughout the platform. For the ingest pipeline, it gives you capability to filter, validate, and transform. And we'll go through the examples of these functions and how to extend them a little bit later in this presentation. But the key is that you want to have an easier way of doing this, and you want to have a reusable set of functions and libraries that you can quickly filter out things you don't want. So an example would be if you're streaming a whole bunch of metadata and you're not interested in certain things like YouTube, Facebook, Twitter, you can quickly filter out that traffic so you're only consuming the traffic you really need. A validation across the board is validating the fact that all telemetries are ingested in a consistent way. So if you say a particular attribute is an IP address, you want to validate to make sure that you don't get any garbage in that field. You also, based on how the sensors log the data, an example would be, some sensors log protocol as numeric, some of them, log it as strings. So there's a validation framework around that to make sure that the parsing is consistent. And the reason why you want to do that is so that you can hit all of these ingested data sensors or data feeds with a federated query, where if you type looking for an IP address or looking for a protocol, you can hit all of the feeds with a single query, as opposed to custom designing a query for each individual source. The last functionality that Stellar provides is the ability to transform and do certain operations on data being ingested. So things like extracting domains from URLs, extracting TLDs from domains and things like that. So it has a rich set of functions that come with it, and we're expanding it with every release. So our hope is to be able to encapsulate most of the common things that people are doing when it comes to filtering, validation, and transformation within this DSL, so it comes pre-canned out of the box, so you don't have to reinvent the wheel every time you want to ingest a new telemetry. After that, so up to here, you have your parsed, normalized, filtered, validated, and transformed JSON. The native data structure within Metron, as you probably know, is a flat map, so a single level JSON map. The key differentiator for Metron after that is the capability to enrich data. So it has two enrichment capabilities. One is a streaming enrichment and one is bulk. So an example of a streaming enrichment is that it can hook into your domain controllers. So it can hook into Active Directory. It can hook into a DNS server. All of the things that change rapidly within your environment. So for example, as users log on and log off different assets, as the telemetry is going through, it can actually enrich it with Active Directory data. So for any point tool, you can figure out what user is associated to what asset class, where that user is based. And it can also do that for static enrichment. So an example of a static enrichment is when you dump something out of your configuration management database, right? So what machine is what IPs, or what is the sort of the criticality level of each asset? What is a printer? What is a workstation? What is a server? You dump that out of your database into a persistent store, which in our case would be backed by HBase, and then you can do bulk enrichment against the streaming data. So that gives you a capability to build up context around your streaming data. So we don't have a trademark sort of name for this capability, but it's basically everything you know about the data, every aspect of the data coming through, you're able to enrich the feed with. So this and this are both extensible frameworks. So out of the box, it comes in with the capability to hook into key value enrichments and SQL enrichments, both streaming and bulk. And so you're able to extend it for your specific environment to attach it to additional feeds. And the reason why this is important is one of the problems that we often see is the fact that the end users for this, who would be like the SOC analyst and investigator, they have to fumble around through multiple screens when they're trying to investigate various incidents. And I'll give you an example a little bit later on what that looks like. A typical investigation, when we shadow the security team within Hortonworks, takes anywhere from 7 to 9 consoles, where you have to pivot in between and sort of cut and paste information between different consoles to be able to get enough context to have a meaningful action around an alert. And so this automates that process, makes it much easier to have everything already contextualized for you, so you don't have to fumble around. It gives you additional capabilities that you can do a federated search against all your data, and not only the data, but also the enrichment, right? Because everything is normalized, everything is enriched. So you can do geospatial queries, so query for things within a region. You can query things based on the user, which not all your sensors are able to capture, right? But because you're doing enrichment, you can actually search for that. And from the perspective of data science and machine learning, it gives you a better ability to do scoring in real time, because if you want to do real-time feature extraction against your data, a lot of the models are built based on some of the features that come from the message, but also some of the features that come from the enrichment, right? So if you're doing user entity behavioral modeling, for example, you have to know who the user is, so sort of the fundamental piece of knowledge that you need to have. And the key for Metron is we're trying to deploy as much analytics as possible into the streaming pipeline. And for the model to work, to score data in real time, you have to have all of that, all of the features that are available to the model, so it can do its scoring. So that's why we do a lot of it in streaming. So here's where we get the context. The next part of the pipeline is dedicated to labeling the data. So we integrate with threat intelligence feeds. So we can do, again, bulk storage. So depending on the number of feeds that you're getting, we can integrate with multiple feeds. We can integrate with feed aggregators, so things like Soltra or OpenTaxi. As long as you get your feed in like a CSV format or STIGS-TAXI, we can integrate with that. So one of the things you can do is you can bulk store your feeds in HDFS and then bulk score against your data going through the streaming pipeline. Or you can stream them similarly to what you've done with the sensors. So as your feeds are coming in real time, you can score or cross-reference the data against them and then have a individualized retention policy for the feed. So the indicators expired based on configuration or how you pre-configured the system. So these are rules-based configuration that you set up within Zookeeper, which knows for any thread feed which field within the sensor the feed corresponds with, or different indicators within the feed correspond with. And it's able to, based on a DSL stellar functions for doing triaging, it's then able to annotate the message with specific things based on what it finds in the feeds. And I'll talk about that a little bit later on. Another thing that it does is it does scoring of the models here. So the key here is you want to do some things that are coming from the feeds, right? So you want to be able to leverage external knowledge, right, from other sources to cross-reference against your data. You also want to be able to apply machine learning, and you want to be able to apply rules, right? And so the reason why you still want to be able to apply rules is because there's some fundamental things within your platform you can't quite get away from using rules, because those are the things that should never occur, and you know that they should never occur. But what happens is a lot of the point systems that we stream into the platform are signature based, right? And beyond the fundamental rules, they're very bloated with additional rules, which makes them very difficult to upkeep. So one of the things we find is that people that heavily rely on these rules-based signature systems, they consistently fumble around adjusting the rules. And so one of the ways to alleviate that is with introduction of machine learning. And so we introduce, and we'll go over that a little bit later on, a capability we call model as a service, which just gives you the capability to deploy a machine learning model as a black box onto the platform. And the way that model as a black box interacts with the stream is through the scoring model apply functions within Stellar, right? So you cross-reference the data against the external threat intel feed, you apply machine learning to the data, and then you apply a triaging rules-based engine that you can either pivot against the things you find in your threat intel, in your model application to the data set, or just create rules on your own saying, if certain things occur within a certain time frame, then apply certain transformation or apply certain severity score, or adjust the severity score in certain ways, or adjust the confidence score of an alert in a certain way. And then the last set of modules that Metron comes with is for storing data in the data vault. So we'll go over that in the later slides. But basically, once you've processed your data, you have it fully contextualized, fully labeled. Where do you want to land it? So you can land it in an index. So we support Solr and Elasticsearch. If you want to have interactive query capability for that data set, you can land it in HBase if you want key value type, if you have a key value type use case. So an example of that would be something like streaming enrichment. So you would back that via HBase. And lastly, you can dump data into HDFS and then iterate over it with Spark-based tools. Things like Jupyter and Zeppelin, and we'll go over that in later slides. So the core differentiations for Metron. So number one is scale. This is built on technology called OpenSock, which came out of Cisco a few years ago, and Cisco ran this at scale, and it scaled to millions of messages per second, and so it ran. At the time, it was one of the sort of largest throughput systems of its kind. I'm not sure how it stacks up today, but it's backed by Storm, so it's quite capable in that respect. So it does what I mentioned. It does streaming enrichment, threat intel, and stellar operations at scale. So that whole pipeline works via streaming and works at a scale of million messages per second and is horizontally scalable. So I think that the figure from Cisco was 1.2 million on a 15-node cluster, right? So it's horizontally scalable at near linear capacity. So no one has tried running like a 100-node cluster, but presumably if you ran it on a 100-node cluster, you'd receive linear performance boost from additional servers. So does data labeling and model scoring at scale. So again, everything or most of the system works via streaming, and so scoring data at that scale is something that's possible within Metron. It doesn't leverage any proprietary format. So we've thrown around supporting Ceph or supporting whatever the MITRE format was, but at the end decided that we probably want to leave it up to the user to format the data in any way they want. So we don't have an opinion on that. We just provide sort of a rough guideline of what you should be doing, and sort of leave it up to you as to how you want to ingest your data. So provide extension points, which is around parsing. So we'll show you the architecture. We provide a really easy way for onboarding additional sensors via Java, Grok, or additional capabilities. Extensible enrichments, plugins for enrichment, right? So hook into additional sources within your data center to be able to enrich your data with extensible threat intel. And again, as I said, rules-based threat triage via streaming, which works at the scale of the ingest. So that's sort of the important point is the rules engine is not the bottleneck for the system. The bottleneck for the system is actually the indexing. So the rules is faster. The rules engine is faster than the indexing. And then all the good things, right? So it's open source, Apache governed, uses only open source technology, right? So works on Hortonworks distributions, Cloudera distributions, Open Hadoop. So with Hortonworks, it's nearly integrated into Ambari. So next week, it'll come with Ambari. Basically, it'll be a button. You click it, and Metron gets installed in your system. CDH supported via Ansible. So currently, it's currently, we support it from Hortonworks, but we're hopeful we can sort of pass it along to the community, and then the community can support this capability. And then we also support running on Open Hadoop. provided it has all of the prerequisite tech that I mentioned in my previous slide. And then we don't have a problem running on top of it. And so it's free, right? Deploys on commodity hardware. And you can run it self-supported or by enterprise support. So we have customers that run it in production that buy support. We have customers that run it in production self-supported or do POCs or kick tires. You know, there's different types of adoption that you can have with it. So the second use case that we're trying to account for, and this sort of has been pushed a little bit further down on the Metron timeline, and I'll share with you what that timeline is a little bit later in this presentation. We received probably about 6 to 9 months ago a lot of interest, from the community in supporting this use case, and then the interest sort of fizzled out. So we partially built it and then used the capability to do other things, and then we'll need to come back to it and eventually finish it up. But what it is utilizing the Metron streaming pipeline, the things that I showed you in the previous slide, and sort of supplementing it with some additional capabilities to provide an evidentiary store on top of Metron. So what that entails is capturing data from the sensor by using either something like NiFi or Minify, basically any type of tool that can capture lineage and record that lineage within the event itself. And then Metron will provide the capabilities for parsing that message with lineage. So basically a seamless handoff between edge processing and core stream processing. Sign the message, tag it, and push it into the data vault, into HDFS. Where we can define a retention policy and access controls on top of that data. To basically turn your data vault into an evidentiary store system. So it will be like a value add on top of everything else that you're doing with Metron, right? So our preferred stream processor or edge processing of choice for that would be NiFi, Minify. Not because it's a Hortonworks product, but because it's sort of the only edge processing framework that we know of that can record full fidelity lineage for the data as it captures it and as it routes it throughout your data center until it actually ingests it into Metron. All that can be recorded. So we're not aware of other things that do it. If we do find other things that do it, we'll gladly extend support for that. So encryption and access control via Hadoop security projects, right? So Ranger and things like that. Custom message tagging at scale. So that already exists via Stellar. We just need to add a couple of additional functions to support specific functionality required for the evidentiary store use case. Reusing the Metron streaming pipeline. And the reason why that's important is because that's been tested at scale. So your evidentiary store can work at the same scale as the rest of Metron. As far as data retention for your evidentiary store, right, using HDFS under the hood, so which is the cheapest possible storage you can have. And when you want to churn through that data, you got MapReduce and Spark sitting on top of that data, so you have horizontally scalable compute. And then all of the other niceties that come with the system, right? So works on commodity hardware, works on any distribution of Hadoop. You got the Apache community behind it, and all the good stuff around that. The other two use cases we're targeting sooner than that use case is real-time search and threat hunting. So we support Solar and Elasticsearch. And so our sort of preferred solution right now is Elasticsearch, just because Solar doesn't have a viable UI that we can put on top of it, while Elasticsearch does. Excuse me. And then also exposing the data via Hive in HBase, right? So Hive gives us JDBC, ODBC capability to expose data through Hue or other tools that integrate into ODBC, JDBC, or doing key value data access via HBase shell. And so the real-time search is covered primarily by Lucene. So we use as much out-of-the-box Lucene as we can. We have previously supplemented Lucene with custom widgets that were addressable specifically towards the security analytics use case. So we stopped doing that, and now are primarily concerned about meeting the same things we did with custom widgets in Kibana by doing stuff within streaming to attach specific fields or tags in our data, so we can account for that capability without having to design custom widgets in Kibana. So that's our current plan. And threat hunting involves providing capabilities and out of the box dashboards within Kibana, and we'll show you an example of that a little bit later on, to give analysts the capability to slice and dice the data and sort of iteratively explore all of the things that have been captured by the system to be able to get down to a specific instance of something they want to follow up on or investigate or do a forensic follow-up on. So again, for the real-time search and threat hunting use case, and I'll later show you models of Metron, and they'll map directly to these use cases. So depending on what it is that you want to do, either if you're trying to extend Metron or if you're trying to build other functionality on top of it, it'll be fairly obvious which component of Metron you need to extend. So again, works with Solar Age-based Elasticsearch out of the box. Everything's extensible, so you can account for whatever use case you're trying to do with it. So again, it inherits all of the things that Metron does, right? So the custom retention periods, integrates Hive, provides ODBC, JDBC connectivity into other tools, and then all the niceties you get, boilerplate Metron stuff. Another use case that is available today in a beta form is a cyber forensics capability. So this is a capability to hook into a core switch or any switch and be able to capture telemetry with commodity capture cards, and provides you a capability to horizontally stack these. So the legacy open source code base that Metron inherited was based on a Napatech capture device, which was fairly expensive and pricey. And as we're trying to sort of bring this to the masses, we wanted to figure out how to do this in a more cost-effective way. So we developed a special probe that can work on top of a commodity card, and we were able to stack these cards horizontally to scale up to whatever traffic capture requirements you have. And the probe itself is based on DPDK technology that runs on top. It's geared primarily towards Intel family of cards. It also supports one Cisco card and a couple of the other smaller players in the field as well. And so the idea here is that you basically you capture packets with these capture devices and stream them directly into the data vault. You store them as sequence files, so you don't store them as PCAPs. And then you provide a series of services on top of that data vault that allow you to iteratively explore PCAPs or explore packets on HDFS. We have a service called Query Inspector that is a command line script that you can go in and interrogate the data into HDFS without having the need to pull it back. And then we provide a variety of querying mechanisms for PCAP. So queries and filters, again, backed by Stellar, where you can construct really complex queries against petabytes of data in your data vault. All of this is backed by MapReduce jobs. And the output of those queries is a PCAP file, which you can then load into Wireshark or other tools for forensic inspection. And so the idea is that you use the threat hunting and interactive search capability to sort of filter through the data and drill down to a use case or drill down to a net flow or a conversation that you're interested in investigating further, and then pivot into this service to then pull full fidelity PCAP for that, and then be able to load it into a more capable analytic tool that's designed for the forensics use case. Be it Wireshark, be it, if you want to do file extraction on PCAP, load it into IDAPRO or things like that. So the differentiation for Metron with respect to that, right, is again, like I said, uses commodity network cards to capture the traffic, uses commodity hardware for every step of the pipeline, right? So capture it, store it, query for it. DPDK, right, open source technology, open source probes to be able to capture it. Compressed via sequence files, right? And then we provide the 3 layers of services on top of that, which are also extensible, right? So the inspector allows you to look at network packets sort of as a de facto PCAP, like it represents them as PCAP, but they're really not. So you can use as, you can look at massive data storage on HDFS without having the need to pull it back. And then if you need to pull the PCAP back to then load it into like Wireshark or other forensic tools, 2 layers of services, you can do a basic query, or there's another script that allows you to construct a really comprehensive stellar expression where you can do really complex queries against petabytes and petabytes of stored PCAPs. And then all the niceties again that come with Metron. Another tool or another use case that we're trying to hit a little bit later down the road is backed by the same infrastructure, but targets 3 slightly different use cases. So number 1 is dashboarding and alerting. Number 2 is exploratory data analysis. And number 3 is audit and compliance. So our plan is to provide dashboards and reporting and audit and compliance via Zeppelin notebooks. Run it on top of Spark. So the idea here is that you have your SOC runbooks that you can automate via, thank you. That you can automate via Zeppelin dashboards, and then you can share them across the organization. So, and then for exploratory data analysis, which is more data science-centric use case, we would use Jupyter to also hit against Spark. The same data in the same data vault, but represented in slightly different ways. So Jupyter is a great tool for using PySpark and RSpark to really get down to exploring data and modeling the data and trying to figure out what it is that you've got, while Zeppelin is a great tool for constructing dashboards and having the ability to share that across teams. So audit and compliance and dashboarding are going to be built around Metron or built around Zeppelin. So it'll come with some pre-canned notebooks that address both of these use cases, while Jupyter will come with some pre-canned use cases or pre-canned notebooks that have examples of exploratory data analysis that's security specific. So you can see how our data science team works, creating a lot of these security models. So we'll put a lot of sort of best practices into those notebooks, and we are planning on open sourcing it, obviously, putting it out into the open source so people can sort of leverage some of the things that we do and hopefully build on top of that. With additional exploratory data use cases, we would recommend using other tooling via Hive. So a lot of the tools that we commonly use or I have seen used with Metron via ODBC, JDBC integrations, things like Gephi or Tableau or Power BI, also exporting stuff into Weka, right? So, and basically any other tool that speaks ODBC, JDBC that you can do analytics on, you can hook it into the system, assuming that the query you pull back is actually, you can actually pull it back into your machine's memory, right? So, again, restating what I said, right? That's the wrong one. So scalable compute, right? Via Spark, MapReduce. Shareable dashboards via Zeppelin, right? Using Spark over HDFS. Integration with third-party BI tools. That is something I cut and pasted from the wrong slide. And then all the other niceties that come with the rest of Metron stuff, right? So exploratory data analysis is its own unique use case, primarily backed by Jupyter instead of Spark or instead of Zeppelin. And so our intent is to provide some notebooks in R and Python. So I'm an R guy. A lot of the guys in our data science group are Python guys. So I'll probably do a lot of R-style notebooks, and then the other guys will do a lot of Python-style notebooks. But the gist is that the Zeppelin notebooks will be more towards like reporting and compliance type use cases, and these will be more of a data science centric. And then integration with other tooling here. And then for audit and compliance again, is what I just said, is use case backed by Zeppelin. The next use case is we're targeting, and they're also getting pushed out in favor of doing that other stuff that I showed you a little bit sooner, but then eventually we'll get to this, is a thread feed analytics use case. So for our ingest use case, what I showed you is it actually tries to evaluate the thread feed as it's coming into the system, but it doesn't discriminate what it actually lets in and what it doesn't let in. And so we're planning on extending the seller DSL to actually work on the feed before it gets into the system, right? So because we have other enrichment feeds, we know the relevance, right? So for example, if we know all the types of applications that are installed in our system, and we know we don't have Windows boxes, and then we have an indicator that's for like a Windows-based machine, we can just drop it. We don't have to ingest it into the system. We can also have auto-confidence scoring before the feed actually ever gets into the system, right? Because we know who's who, because we're integrated with Active Directory. So if the feed is hits against something that is a high-value asset for a high-value user, we could sort of pre-process it and adjust its severity scores, and if we also get that indicated from many feeds, we can automatically adjust its confidence scores without actually needing to interrogate the rest of the system, right? So we can either not let things in or let things in based on specific confidence and severity scores, and drop the noise before letting all of this stuff in. And then also do auto retention, right? So for important stuff, you want to keep it longer. For less important stuff, you want to keep it for less long, right? So having all that capability before the data actually hits the system as well. So that's on our roadmap also. And then, so just to restate what I said. And then the machine learning platform, which is currently in beta form, but is all out in Apache, so you can go take a look at it. We're pretty excited about that. This got pushed out a few months ago. And so it's sort of a beginning of a more comprehensive machine learning framework that sits on top of our system that, as I mentioned, has a batch component and a streaming component, but the streaming component is able to work at the scale of stream processing. And so at the core, what we have is a model as a service, which gives you a capability to onboard your model in any language, so Python, R, Java, Weka-based model, whatever you choose. As long as you implement specific extension points, you can just drop it on to Metron and use model as a service to do model training. So you can access data stores, so either anything in your data vault, and then we provide additional data abstractions and feature stores that are specific to security modeling that we commonly do and we know we need, and people that build models on top of Metron will likely need as well. So we provide those as well. So one of the things we provide is an entity profiler. So that got pushed in about a month ago. This is a framework that does feature extraction and entity mapping for different types of entities in your system, right? So an entity can be a user, an asset, or any component, any feature of your message. So it does full fidelity profiling of it. There's stellar functions to configure it, so you can say, whatever types of statistics you want to keep around about the entity, you can configure that, and it's also extensible. So if you want to do something it doesn't do, you can extend it. It provides an ontology mapper, so it's one of the capabilities we're currently working on. Should be coming out in the next few months. The ability to take disparate information from disparate sources, fuse them into like a graph database via ontology mapping, and expose that to your machine learning model as well. So not only does it have your entity profile, it also has the relationships of how these different entities relate. And then there's additional features that we can't talk about quite yet that, at least on the Hortonworks side, we're planning on pushing into the platform. Again, this thing is available now. This thing will be available in about a month, and then there'll be additional things coming out. All of it is accessible, so both raw data as well as the feature stores are available via a unified API, and that's primarily for model training. If you remember, the stream ingesting pipeline had the labeling phase. And so far, we've been talking about the labeling phase, from the standpoint of security investigators and the analysts. But the labeling phase is actually extremely useful for applying supervised machine learning for your data, right? So you have your fully enriched, contextualized data in your data vault and is labeled, right? So now you can all of a sudden start training classifiers and supervised machine learning on top of that. Plus, you get the benefit of all the other stuff. So that's for the batch component. For the streaming component, it's backed by Yarn, so you get service discovery and resource management out of the box for any model that you drop onto model as a service, provided you have the right extension points for it. So the discovery service is backed by Zookeeper, and it'll basically it's a configuration that gets pushed in. And a Stormbolt is able to figure out which models are available and what services these models provide, and how to interact with them, right? So what is, if it's a RESTful interface, what is the RESTful signature? So it's actually able, as it gets all of its features from the enrichment, it's actually able to take that and send it to the model, and then get a model response back. Another thing that it does is resource management via Yarn. So depending on the kinds of models you're deploying, some of them might require lots of memory, some of them might not, some of them might require locality, right? So if your model requires GPU acceleration and you have a subset of your nodes that have GPUs on them and some subset that doesn't, you're able to define locality and able to define resource management also through a Yarn-based integration. So all you have to do is extend the right extension points with your model, drop the model. The model will have all the capabilities of reaching data in your data vault through a unified access API, and then immediately train the model, have that model be discoverable, and then through full resource management, have that model do the scoring at the speed of your ingest. So while all of the other more basic services of Metron are functioning, like enrichment, integration against threat intel, your application of your machine learning can function at the same scale. So that's the idea behind that. Let's see if there's anything I forgot. So again, restate what I just said, just so we're all clear. So model as a service, right? So three main benefits: scalable scoring, automated service discovery, automated resource management via Yarn. And then some of the other niceties that we provide, right? So your entity profiler is built in, so you don't have to reinvent the wheel on that. Your ontology builder, so seeing how all of these entities interrelate, will come out in about a month. And everything is backed by Stellar, so if you needed it to do in terms of profiling or in terms of ontology mapping, if you needed it to do something that it doesn't already do, you can extend it. You can extend a Stellar function or add your own Stellar function. And if you wanted to score data in the way that it doesn't already do it, you can extend that capability as well. So now it has two functions within Stellar. I think it's model discover and model apply. And you can then, if you have something custom that you want to do, you can extend that capability as well. So let's see. So this is the tentative timeline and a set of milestones that we're looking to hit. So the initial 0.1 beta with the real-time search and ingest capability came out around April of 2015. It's been out there, so if you've been playing with Metron, you've probably seen these components out, and they've been sort of refined over time. Around June of 2015, we released the second beta of these, had some additional capabilities in them, and released the beta 1 of the cyber forensics solution, and made it a little easier for these two to sort of go between each other. And then in November, we're planning our 1.0 release in Apache, so that'll be a pretty exciting time for us. We will, again, have a 1.0 of our ingest use case, the real-time search use case, and the cyber forensics use case, and then the machine learning stuff will still be in beta, but a lot of it is already out there. There's just a couple of components that we're missing, and all we need to do is really just refine it. So as more people are adopting this and people are running this in production, that they provide feedback, about stability or different types of features that we haven't accounted for that we need to throw back in there. And once that is out there, hopefully by sometime late winter of 2016, we want to do some enhancements for search and ingest, have the ML stuff be 1.0, and then solidify our dashboarding strategy, and then provide additional other capabilities into forensics. So additional capabilities to query, additional capabilities to stitch packets together. So for what's out there now, how does it all relate together? So the way we try to stitch them together is, as I mentioned, the core enabling use case for Metron is ingest and correlation. If you wanted to sort of distill the data and have it interactively searchable, then you take the real-time search module and plop it on top of that. So those are the things like your Solars, your Elasticsearch, your Kibanas of the world. If you wanted to have a capability of interactively searching the data, and then once you found it, pivot into forensics, and then pull up a PCAP, and then explore the PCAP, you want to pull this guy in, which will provide the forensics capability. And then if you wanted to start deploying models on top of the platform, you want to pull in the last guy. So think of it as like an algorithmic assistant. And you can tie it all together with the streaming pipeline, right? So as I mentioned, you can hit against threat intel, you can hit against machine learning, or you can hit against your deterministic rules. And based on what you pull in, you can define your rules as to how you want to proceed with your telemetry. So this is a real-time or a real-life use case example of how Metron was used, and specifically on a case that we had here at Hortonworks. One of the more common attacks that we get is phishing attacks. I'm sure everybody's familiar with those, and everybody gets virtually thousands of them per day or per month. Right, so this is where a fake, fictitious email gets sent to you. It tries to bait you into clicking on something. It looks legitimate. It looks like it came from a legitimate user, right? And you click on it, and then something not legitimate happens. And so we have lots of those here at Hortonworks. And one of the more common ones that we get is a DocuSign type phishing attack, where and a lot of employees are getting this, and I think I've gotten a few of those too. You come in, and somebody from finance send you an email about a new stock grant that you've just got, and you haven't been told about it, right? So you become really happy and say, oh, I got some new stock. And of course, you want to click on it to see how much you got, and then when you click on it, something bad happens. And most of the time, it's either there's like incorrect English, or there's something about it that gives it away. But there have been a couple of good ones that came through that it was really, really hard to determine if they were legitimate or not. And I'm going to go over this. So this is what happened to us fairly recently, a few months ago. So we had a user that contacted our security team about what he thought was a potential phishing email, and so he received an email from finance, basically saying, hey, you got a new stock option grant, but before you can accept it, you have to go into DocuSign and sign all these documents. So the user clicked on it, right? So there was a link in the email, and a legitimate like SSO-looking thing came up, asking him to enter credentials. So the user entered the credentials, nothing happened, and so the user kept repeatedly doing it. Nothing kept happening. So he eventually contacted the sender, saying, why, as I keep on doing it, nothing's happening. And then the sender said that the sender never actually sent the email. So the receiver became suspicious, contacted the SOC team, and then we had an investigator pick it up and start trying to figure out what the problem was and what the extent of the damage was. So if you go through sort of the story unfolding in real time, so think of it as sort of you looking over the shoulder of a SOC analyst or investigators as they're going through their investigation process, right? So the first thing is we have a SIM, right? So we went into a SIM and we searched it, and we had two users that were impacted by this, right? We had user Sonia and then the whoever the receiver was, Ethan. Right, so we searched the SIM for any information relating to these guys, and whatever the IPs are associated with these guys. So far we really know nothing about them. The only thing we see is that the email came in from some Gmail corp account, using some IP addresses. The next thing we needed to do was we go into a Maximind geodatabase, try to map these IPs to see where they're coming from, and then we discover, right? So this user Sonia has a set of IPs that the traffic to her originates from and to, and then we have IPX that is from Ireland, and IP1 is from Southern California. So that immediately sort of sets off alarms, like how can you have a user be in two places at once? But then what we need to do is go into your identity management, your Active Directory, trying to figure out where's that user based, and who is that user, what assets belong to that user. Sort of trying to establish, of these two, possibilities. Right? Is the user in Ireland? Is the user in California? Of the two IPs that are associated with the user, which one should be and which one should not be? And so for us, our security team is not allowed to access Active Directory, right? So we have separation of concerns. We have to contact another team, file a ticket, and wait for the dump of this data to come to us, right? And then eventually, maybe a couple of hours, maybe a day later, we get this notification of this. And what we learned from this is the user is actually based out of LA. Right, so that would explain why one of the IPs came in from Southern California, but this still does not explain why there was another access from Ireland. So then we need to log into an asset management inventory, trying to figure out which assets are associated with that user. So the user in our case had a couple of laptops and a company phone and all of that. So out of all of the IPs that we got from the SIM associated with that user, we need to figure out which ones are actually legitimate, belonging to that user, and which ones are spoofed, right? So for that, we needed to go into an asset inventory. The next thing we needed to do is, once we figured that out and we had all that traffic, we wanted to run it against the threat intelligence feed to see if there's any indicators, and sure enough, we got a hit on one of the IPs that the user was using. So here, we became really suspicious, right? So all of these things look fishy, and then now we get hits against threat intelligence. So something, there's really something bad happening here, right? So all of this is something we needed to do to add context to sort of a simple ticket just so we have enough awareness to be able to determine if it's a false positive or a true positive, and start to sort of generalize as to how serious this is. And so again, we needed to go back to the SIM and figure out, well, what kind of traffic, what kind of applications is this user using, and how did this come about, right? So we figured out, we found a set of emails that the user was exchanging with other users, right? So we log into a Fire system, which is our email analytics systems, and then two additional systems that we use as Ironport and Intermediate to be able to. So FireEye sort of gives us a general idea of what's in an email and like a quick blurb, and then if you wanted to analyze it in full detail, and then also pull in all the attachments that came with the email. There are two additional consoles that we had to jump into to then recover that email and analyze it, right? And so the first one gave us a scope, right? So we were trying to figure out, if this user is legitimately bad, what other users, did that user contact, and what type of email did that user send to other users. And then once we figured that out, we needed to do the forensic investigation, just saying, how much of that actually succeeded, who clicked on what, and what was compromised, right? So after that, we go through remediation steps, right? So what kind of things we need to do, right, is we need to Exchange, go into Exchange and edit permissions there, right? We needed to go into corporate Gmail accounts and deactivate users or suspend users. And so this happened around the time where we originally used Gmail, but then we switched to Exchange-based email. So that's another thing that tipped us off, is that we had domain knowledge of our network, and we knew that the corporate Gmail system has been decommissioned for about a month, and so that's not something the attackers knew. So anything coming from Gmail was likely not legitimate. And then Active Directory and single sign-on, right? So we had to go and pull user credentials and reset user accounts and things like that. So here's how this thing unfolded, right? Is so it was like originated as a social engineering attack where the attacker tried to prime the user with some fake emails, and then the user sort of thought that the person was real, and then all of a sudden that person built enough sort of rapport with the victim, where the victim actually thought that started accepting communication from the user, right, and then sort of the thing propagated. But what you should know is the case from its inception to the end took about 2.5 to 3 weeks to investigate, right? So it's fairly pedestrian, run-of-the-mill phishing use case. Took that long. And the reason why it took that long is not because our people are bad, but the reason why it took that long is because we had to jump around all of these different all these different tools. We had a high degree of dependence in other teams, so we had to request information. We had to wait for information. It took us a while to not only piece together context, but also sort of assess scope, and then trace through this stuff to figure out the impact. And that's a fairly laborious and fairly manual process that we are not happy going through every time we get an alert like this. So that was the challenge, right? And this is the sort of what we're trying to address with Metron. So how does Metron solve that? Via enrichment and integration with all of the other sensors and threat intelligence. Is we're trying to remove this, and this, right? So trying to accomplish everything via stream processing by automating integration. And the only thing we don't want to address is remediation, right? So how you, once you figure out what's happening, how you want to affect your Exchange server, your Gmail, your Active Directory, and Okta, it's up to you. So we're not planning on automatically remediating threats, but everything else, sort of in our charter, is we want to try to be able to automate, right? So to restate that, map against existing use cases, right? Take everything that's known about a threat and check for it in real time, right? So we have that. So make easier and faster to find issues. We have that. provide a single pane of glass so you don't have to jump around between different consoles. We have that. And then provide a layer of machine learning when the threats are advanced to be able to detect them in a more sophisticated manner. We are well on our way to providing that. So as I mentioned, pieces of that already exist, and then within a few months, more will come out. So how does that map to things within what's in Apache today? So there's 4 pieces to Metron. It's platform, sensors, deployment, and analytics. So platform is the core. So most of the capabilities that I've talked to you about today are available from the core project. Sensors are things that come out of the box with Metron. So out of the box, it's integrated with YAF for NetFlow, obviously the PCAP probe that I've described, BRO for deep packet inspection, and Snort for alerting. It's deployable in multiple environments, so it can be deployed on a laptop by using a combination of Ansible and Vagrant. It can be deployed on Hortonworks managed clusters via Ambari. It can be deployed on Hadoop and Cloudera clusters via Ansible. It can be deployed in 2 modes to run on your laptop. One is sort of a single node development environment, and 2 is a multi-node representation of the real environment, assuming you have enough sort of oomph on your laptop to be able to facilitate something like that. Generally, when we run it on a laptop, not on a cluster, we have to shut down specific services to be able to run it on like a MacBook Pro. So we can never quite stand up the whole system. So it's a very delicate balancing game between which services you bring up and which services you break down. And then the analytics stuff is all things machine learning, which is what I mentioned before. So I'm not going to go over this in painful detail, but these are the modules on the platform. It's pretty self-explanatory. And all of these have extension points. So if it doesn't already do something you want it to do, you can extend it. On the analytics, so 3 things are available today. So model as a service common, which is the framework that I mentioned that you deploy models on top of. The Metron model as a service that is the piece that you embed into your model for the model as a service framework to be able to uptake that model. And then the profiler, which is the thing that I mentioned, it's something that profiles your entities so you can build anomaly detection and sort of user entity behavioral models on top of your data. And so one of the things I wanted to underscore here is our intent is not necessarily to provide machine learning, it's to encourage other people to build machine learning on top of our platform. So we'll provide a couple of models to seed the ecosystem, just so people can get benefit out of the system, out of machine learning, out of the box. But what we would like to have happen is for people to leverage the capabilities that we provide to build a machine learning ecosystem on top of the platform. And we'll work with the community to sort of facilitate that functionality, and where there's gaps, we will address them. But we'd like to encourage the community to provide modeling for us. And then on the component side are all the installers, as I mentioned, right? So for Codelabs, so things like this Meetup or other Codelabs that we do, there's a special platform, special installer that builds a Codelab platform. For testing PCAP and ingest on your laptop, so when it's not the real thing, when you just want to sort of see how it works and kick the tires, you want a fast Kappa test platform. So full dev is a multi-node cluster for your laptop. Quick dev is a single node cluster for your laptop. Again, multi-node Vagrant is a Vagrant-based deployment, and then Amazon EC2, it builds out your whole cluster. In Amazon, so this is the best deployment you should probably use because it rolls out and turns on every single feature of Metron by default The only thing it doesn't turn on is the topology to pipe PCAP into the system, and the reason why it doesn't do that is because it makes running the cluster in the cloud very expensive, because PCAP is your highest volume source, and if you start piping in a lot of data, your Amazon bills can accumulate quite quickly. So that is turned off by default, and then we provide instructions for you to turn it on. So if you want to deploy a fully capable Amazon EC2 cluster, it's as simple as exporting your Amazon keys, making sure you're able to provision at least 10 nodes within Amazon, kicking off a script, walking away, coming back 2 hours later, and having the cluster or having Metron be rolled out for you, both the core as well as all the peripheral sensors that are required for driving the platform. And then next week, we'll have integration with Ambari, so very similar type of thing. There'll be a management pack that runs on top of Ambari, where you set up your options, you click a button, you walk away, come back an hour later, and the Metron application's installed on top of your cluster. So that's the vision on that. And that's the end of my spiel, at least for the introductory part. So let's see. So you guys have any questions about what you've seen, comments? Go ahead.
Yeah, for the Ambari integration that you were mentioning, are you using the existing HBase and Zookeeper, or are you spinning up a separate instance?
Using the existing infrastructure, yeah. Is that the only question? Go ahead.
For the rule correlation, it's just based on very basic spreadsheet correlation, or is it more complex, temporal rules and all that kind of stuff?
It doesn't have temporal right now. It's just sort of a rules-based, non-stateful correlation at this point, but the plan is to add state and add additional features like windowing on top of that as well.
High priority thing, or is that very
It's partially supported via entity profiling, so you can get to it. It's not very well integrated. So to rephrase that, it exists. It's not very well baked into the system yet. So that there's a lot of.
That's real time.
It's in real time. That's right.
And the data store for that is HBase.
It's backed by HBase. Go ahead.
So how does this differentiate from, say, Splunk or another log analysis? Is that just the streaming aspect of it, or?
So it's open source, right? So it works at a fairly large scale, right? So supporting a lot of stuff, up to millions of messages per second in streaming, right? It does all your machine learning at scale. It does all your stream processing at scale. Integrates with raw packet capture. What else does it do that Splunk doesn't do? I think those are the main points of differentiation.
About the enrichment of pipelines.
Yeah.
And so, Splunk is great at indexing data that comes into it, but what this is doing is also correlating other data sources, enriching that data as it comes in. So adding, multiple joins to that. There's things like the rules framework into the ingest phase as well. So it's doing quite a lot that traditional log aggregation tools don't do.
Yeah, and you can never apply machine learning via streaming if you don't have that. If you don't have the features available to the model, right? So from the modeling perspective, that's core differentiation. Another question.
So the numbers from Cisco are pretty old. It's been a while open source, like those benchmarks were run.
Sure.
They were primarily run on packet capture data. They were not run on real log data, which is quite a lot of gibberish that comes along, right? You're talking about syslogs, which is very format and from systems. Have you guys run benchmarks for that?
Yeah, so it was run on a system as a whole, right? So it wasn't run on just PCAP data, it was run on everything. Those numbers are...
Data is very structured in the sense that if you just take the metadata out, it's very structured. It's a couple bytes. And indexing that is relatively easier on the performance side of the equation compared to something that's free from log messages, which is not structured. I was just wondering if you guys ran performance.
We haven't benchmarked that, but I would argue that because of volume, PCAP is actually harder on the system than the other log types. So the system was benchmarked with PCAP plus 7 additional sources. So that it was SourceFire, some Cisco ASA stuff. What else? Some Bro, and some of additional application, lower volume application logging things. And
Is there any customer or benchmarks you guys have done on specifically
there are customer benchmarks that we're not allowed to publish. They're not at a volume that Cisco ran it, but they're sort of around there. So, and again, we haven't ran it on large clusters either yet. So we don't have a customer yet, or no one has this yet, on like a 50 to 100 node type cluster. So.
So in the Hadoop Summit this year, the bank presented this year, right?
Mm-hmm.
And they have a fairly big deployment, I guess.
Not sure I can talk about that. Yeah, I mean, I know who the bank is. I'm not sure I'm allowed to discuss their infrastructure in the public.
I'm just saying that they have a fairly large deployment in terms of the amount of messages that are processing. Like when you said that there isn't a big enough deployment.
It's a fairly sizable deployment, but it's not, like a 100 node type deployment.
It's fairly big, but not by our standards, right?
Yeah. Go ahead. So it starts with Kafka, right? So as long as you can get data into a Kafka topic, it picks it up from there and does its thing. How you get it there doesn't matter. You can use NiFi, you can use Flume, you can use whatever you want, right? You can syslog it in for all we care. So it's fairly flexible.
So what is the story for the batch processing? Like, is it a large amount of data, like 10 GB or 100 GB they want to go to the search base? Do you have a pipe for the batch processing?
Yeah, so if you have a large data store, you periodically export for enrichment. You don't want to stream it in, obviously, right? You want to bulk load HBase or bulk load your data source. So it provides scripts and capabilities to do that, so you don't have to stream it in. Otherwise, you'll be streaming this giant blob, and then you don't do anything.
Do you have a tool which you put in your framework?
We do, yeah.
Is that direct to HBase or like do you use a tool like direct?
It's an extensible framework, right? So it can back into whatever backing store you choose. We choose HBase most of the time. So the most robust capabilities are built around HBase. By using the bulk ingesting framework. So you put your data into HDFS, you run a script or you run a program. It takes your data, bulks ingests it into HBase. Yeah.
It's using MapReduce under the hood, right? You're bulk loading into HBase. You drop your data, you want to import in bulk onto HDFS. You can you run our scripts which have a custom MapReduce job, which will put it in HBase with the right key structure.
On the enrichments that you provide, they have to also come on the Kafka pipeline, or can they be bulk stores from HDFS?
What was the question?
Yeah. Can you repeat the question?
So the question is, the enrichments that the streaming pipeline provides, do they also have to live or appear on the pipeline, or can they be in a block store like HDFS or Hive? That would still work.
They have to be in a backing store that you can hit in near real time, right? So either SQL or some sort of a SQL solution or key value stores. You can be in Mongo for all we care, right? As long as it's available.
You're talking about applying the Metron process and the enrichments to historical data, or batch enriching against large swaths of reference data.
I was asking for the latter, is as my new data comes in, let's say I've created a list of enrichments in my pipeline. Do I have to reload them, or do I also have to pass them through the Kafka pipeline, or can they be in a block store that we can apply in near real time?
Yeah,
Sorry.
so that's
That's your interpretation is correct.
Yeah.
You can put them into HBase via bulk. It makes sense to stream them like in an Active Directory data and stream them in ingest them in bulk. You have just like a small CSV. There's a little command line utility to some other store other than HBase, you can extend Stellar with a custom function to call out to your store, which just involves writing a Java class and annotating and dropping on the class path.
And if we have to apply it to the legacy data, do we have to run the legacy data through the pipeline for this to?
You'd have to run the legacy data through the Kafka pipeline in order to get it to be enriched. Right.
Question.
Just about your product roadmap. So are you looking to now looking at scalability and then more type of machine learning models? Is that what you're kind of, because you're at the beta phase with your ML, and you're saying that you can't actually, you've never tried 100 nodes or even near 100 nodes.
Would like to get there, yeah.
Scalability a problem as well?
It's not a problem. We haven't scaled it that much, right? We scaled it past what OpenSock was at Cisco,
Yeah.
but just not to what we consider large, right? So our definition of large, I don't know what Hortonworks defines it as. I would assume it's,
1,000.
yeah.
That's when we start talking about large clusters here.
It's also the fact that unless you're NSA, nobody really has that kind of fee. Large corporations usually end up around 1 million fee-ish. If you pour in everything, you're talking about anywhere from 3 to 4 terabytes of logging per day. And that's when you're pouring in everything. At a Fortune 100 company.
So let's be clear. So let's separate the log data use case from the PCAP capture use case, which can get extremely large from a.
Yeah, I mean,
from
if you're doing wire capture, then that's a different.
Yeah.
But
So I mean, the idea behind Metron is you should be able to do both of those kinds of things.
You'd be surprised, with high fidelity logging, plus if you're pulling in machine exhaust data as well. I mean, you can get fairly simple.
like in general, in most companies, you end up around 4 terabytes ish per day, and then you can do compression, you can do a lot more pouring. And I'm talking about a couple tens of thousands servers. I'm talking about around 30,000, 40,000 servers, someone running. With pouring in syslog, pouring in Active Directory, all that fun stuff. But question around the enrichment process. Are you guys using event sourcing for PD live feeds, or is it continuous poll?
Just continuous pull.
But it directly hits that, or it caches in?
It caches it in Storm. The data is live in the backing store. It caches it in Storm, and it has a retention policy based either on size or on time. And when it ages out, it'll hit it again.
Is that configurable?
What was that?
Is that configurable?
It's configurable, yes.
And is configurable based on feed, or just like it's a standard configuration?
It's configurable based on enrichment, on the enrichment type. So if you configure Active Directory, everything that tries to hit against Active Directory will have the same configuration. Any more questions? I think we're good. So the next part of the meetup is generally the Codelab. Just out of curiosity, how many people here are interested in doing the Codelab and sort of following along? Well, one person, two people. Anyone else?
What's in the Codelab?
What was that?
What's in the Codelab?
What's in the Codelab is, so we'll show you some of the extension points. So if you wanted to add new telemetry, new enrichments, we'll show you how to do that.
So is it one monolithic piece, or you can do parts of it?
You can do it in parts, right? So you don't have to do it all at once. So depending on people's interest, right? So if people are not interested in the hands-on piece, the rest of it is going to be hands-on. So for people that are interested in various parts, we can see what people are interested in, and we can just do that. So we're not here until 1 in the morning trying to extend this thing. If you're not interested in the hands-on, if all you wanted just a primer as to what the project was, then. Going back to the roadmap slide to show what is here today. So that is here today so it's between here and here today. So
Are those dates
Yeah, the years are off, by the way. Yeah, I've been meaning to fix that for a while. What was?
Winter of 2016, that's over already.
That's
At least
fantastic.
it's, at least
It's been released a long time ago. There you go.
that's better.
All right. So you don't have to time travel. This is, yeah, so we're trying to get it into here. It's closer to this than this, but it's not quite all the way there. So by November, it should get there. All right, so whoever wants to do hands-on Codelab stays. Otherwise, thank you guys for attending. Thanks for your time. And we are not. So we're currently focused on providing sort of the piping for the models. Currently not